Kia ora everybody. Hayden and one or two other folk have found a question really tough, and that's question 5C on page 133 of the workbook. And so I thought instead of just answering to Hayden, I thought I'd make a video so not just Hayden can see it, everybody can. So what I'm going to do here is I've prepared a little thing here. Question 5C on page 133 has got this situation here where Jason and Janet are driving each other on little bumper cars. Both cars have got a mass of 240. Jason's got a mass of 65. Janet's got a mass of 58. Jason's coming at 2.4 meters per second. Janet's coming at 2.7. We're asked to find out what would be the case if the bumpers didn't work very well and the cars locked together. And if the cars locked together, then what direction would they go and how fast at the end? So this is a momentum problem. So momentum before is equal to the momentum of mass 1 times velocity 1 plus mass 2 times velocity 2. The total momentum initially is going to be equal to, before we do anything, we need to know which direction. I'm going to decide that this direction is positive and this direction is negative. You can choose either way, but it doesn't matter as long as you stick with the program. Jason's mass is first, so he's got a mass of 240 plus 65 makes 305 kgs, because you have to, oh boy, I don't like this thing. I just cross it out and start again. 305. My machine is making my life tough for me. We'll try one more time. 305 kgs, because it's 240 plus 65 times, now this is going to be a positive number, 2.4, because it's going to the right. We're going to add on to that the mass of everything in Janet's car, which is her car plus her mass, makes a total of 298, because I just get myself my laser pointer here. 240 plus 58 is the total mass that's going this way. So that makes a total of 298. If I then come back here, it's going to have a velocity of 2.7, but that's going to have a negative velocity because it's going to the left. Now we find out what these things are, and I've got myself a little calculator here. Like you, I'm using my phone as a calculator. So 305 times 2.4 is going to give us 732, which is going to be a positive number, and then add on a negative number, which is going to be 298 times 2.7, 804.6, which is negative. That's going to be a total of negative 72.6 kgs meters per second, in other words, to the left. We know that the wreck of the two of them will be moving to the left. Now we're going to find the final velocity of the whole thing. We're asked to do that. So what I'm going to do here is the momentum is equal to mass times velocity. That would mean that the velocity is equal to the momentum divided by the mass. So the velocity will be equal to 72.6. I can use the positive now because I've decided it's going to the left, divided by the total mass. Now the total mass will be all of the masses together, so it's going to be 305 plus 298 because it's all together. The velocity will be 72.6 divided by, let's work out my little calculator here, divided by 603. So 72.6 divided by 603 is going to give us 0.12 meters per second to the left. Now I'm going to have to check in the back of the book before I sign off this little video here. And we're on page 133. you have a hold up. I didn't think about checking for the answers at the start, but we'll get there, guys. No trouble here. Where are we up to here? Page 133. I don't use the back of the book much, but I'll give you a hand with this. Yep, the back of the book on page 212, the very bottom right hand side says that the final velocity is 0.12 meters per second, but it doesn't say which direction, but it is to the left. Anyway, I hope that's useful. Cheers, guys.